Hi! Did you try example 3.3, this one right here? Make sure you check my transcript to see if you achieved what you should have, okay? Again, the 4-step process, that's it, okay? All right, well, I'm going to do 2 more with you right now. Don't worry, I'm going to provide you all the transcript. And if you don't think that you need to watch even this one, you don't have to either, okay? And I noticed that some of you guys are having trouble because of your algebra, because there's a lot of algebra and with the factoring going on, okay? So beware of that. Okay, let's try again. Again, we're going to do the 4 steps. I keep doing the 4 steps, right? Step 1, the anchor. Anchor, or I like to call it verify. Okay, let's verify that this formula is true. This one is the cubic formula, right? If I cube n cubed, does it become n squared plus n plus 1 squared over 4? It is. If I add all these in the series, it becomes this beautiful sum. It's a kind of a miracle, right? It's kind of an amazing thing. All right, let's try this. So I'm going to let n equal 1, which means I have 1 term in my series. And that means n equals 1, so it's 1 squared. 1 squared, 1 plus 1 squared, divided by 4. And what do I get here? Does it equal 1 cubed? Let's see, 1. 2 squared is 4, so it's going to be 1. Sorry, I'll just write it. So it's 1 times 4 over 4, which is equal to 1 equals 1. Holy cow, it works. If you think it's too magical, let's try again. N equals 2. Let's try that again. Okay, are you ready? So we're going to go 2, 1 cubed plus 2 cubed. Does that in fact equal 2 squared? 2 plus 1 squared over 4. Let's try it, okay? 1 cubed plus 2 cubed is 9. Does that equal 9? Dun, 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 dun. 4 times 3 squared over 4. Hiya, hiya! 9 equals 9. You're right. It works. Holy cow! Okay? Isn't it amazing, you guys? Okay? All the series, weird series like this, the formulas are all given to you later. I'll show you in a sec, okay? Maybe you saw it already on the bottom. Dun, 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 dun! Okay? All these formulas are really true, and all these can be proven using the PMI, principles of mathematical induction, okay? All right, so now let's do the inductive hypothesis. So I like doing the inductive hypothesis on the same line here, okay? Sorry if my notes are a little bit messy, but hang in with me, okay? Step 2, inductive hypo. Induct hypo, okay? Inductive hypothesis, which means let n equals k. Remember, this what's given to you is p sub n, okay? Not p sub n, p sub n, okay? So let n equals k, which means p sub k is equal to 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus k cubed is equal to k squared, k plus 1 squared, all over 4. We're going to prove that when we add 1 more to this series, it's still true. All right? So that's the second step. Let's go on to the third step. Dun, 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 dun. Third step, the inductive step, the meat. This is the most important, guys, inductive step. Are you ready? Assume, verbatim, p sub k is true. Okay? We're going to assume that p sub k is true. Then, p sub k plus 1 is, again, we take everything that we already know to be true, plus dot 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 plus k cubed, but we're going to add 1 more to this series, right? So it's going to be k plus 1 cubed. But wait, that's the left-hand side. What are we really trying to prove? We're trying to make a goal. Let's make a goal here. Let's make a goal. Let's make a goal. I'm going to make a goal. We're trying to prove this, that all this is going to lead us to this formula, but plus 1, or this formula plus 1, right? Doesn't matter which one, right? K plus 1 squared, K plus 1 plus 1 squared over, all over 4. So actually it's K plus 1 squared plus K plus 2 squared. Sorry, not plus, sorry. Let me fix that. I gotta be very careful here. It's K plus 1 squared, K plus 2 squared. It's like this, like the terms that are next to each other, right? So we're going to prove that to be true. So hopefully when we simplify this left-hand side, it's going to come out to this. Let's find out, okay? Are you ready? Wait, we know that this is just p sub k, right? But p sub k is p sub cake, which is k squared times k plus 1 squared all over 4, right? Plus, we have our lone soldier here, k plus 1 cubed. This one is really algebra heavy, okay? But I want you to know something. I can make things easier for you. So you guys, we're going to actually combine this into one fraction. K squared, k plus 1 squared, plus, I'm going to multiply this guy by 4 over 4. So which means it becomes 4 k plus 1 cubed all over 4. All right. Oh my God, looks nothing like our goal. I know you're getting a little bit worried, but don't panic. Wait, what are the common factors of these? Do they have any common factors? Yes, they do. They both have k plus 1 squared at least. K plus 1 squared at least. So let's pull that out. Are you ready? I'm going to take out k plus 1 squared. And what are we left inside? We're left with k squared plus 4 times k plus 1. 1 is left, right? Right, 1's left. Because we have k squared plus 4, but we only took out 2 of them. So again, if I multiply this in, I should get this back. It's like distributive property reversed, okay? All over 4. Okay, sorry, now I have to move to the right. So it's k plus 1 squared. Oh my God! Wait, we're getting so close, right guys? We're getting so close. Wow, we're real close, okay? But now, this right here, when I multiply that in, I get k squared plus 4k plus 4 all over 4. You're like, it still looks nothing like our goal. But wait a minute, chill out. What's this when you want to factor it? It's k plus 2 squared, which is exactly our goal. Woo! We got our goal! So we proved it. So again, make sure you state your conclusion, okay? Therefore, by PMI, we can assume and we can actually conclude that the Pn is true for all positive integer n, okay? So eventually, you guys, you're going to be able to ask to prove all these, okay? Try that, okay? Now, look at the next example. What the factor? I'm not going to finish this one. I'm not going to make a video of it. All I'm going to tell you is this, okay? When a problem is written this way, what I would like for you to do is write out a few in the series. For example, isn't this just basically 1 times 1 plus 1? That's your first term. Next term, 2 plus times 2 plus 1. That's your third term. That's your second term. Your third term is 3 times 3 plus 1. And this is the actual series, right? So you know what? I'll go ahead and put this as a, I'll write a list first and then I'll show you. Do you understand what I'm doing? I'm just writing out what this series is really doing. So eventually what it becomes is this. This is not as hard as you think. It looks kind of tricky-dicky, I know. 1 times 2 plus 2 times 3 plus 3 times 4 plus 4 times 5. Ah, do you see what's happening, you guys? Plus dot dot dot. So it's the number, two successive numbers that are being multiplied together. And eventually their sum is going to be this, we're saying. So when you're verifying, the first step, or verify or anchor, think of it this way. Let n equal 1. So you're going to say 1 is this. 1 is 1 times 2, right? Does that equal the right-hand side? 1. So it's going to be 2, right? Let's see if it equals 2, okay? 1 times 1 plus 1, 1 plus 2 over 3. This is 1 times 2 times 3 over 3. Hiya, hiya! So 2 equals 2. Believe it or not, this works. If you don't believe me, n equals 2. Let's try 2, okay? So it's actually 1 times 2 plus 2 times 3. So that equals, right? Does that equal, they're asking for n equals 2, right? So the right-hand side. 2 plus 1, 2 plus 2 over 3. We're seeing if this is true. Let's see, okay? This is going to be 2 plus 6, which is 8, right? Let's see this. 2 times 3. We're going to put a question mark there. 2 times 3 times 4 over 3. Hiya, hiya! You're left with 8 equals 8. It's true. So go ahead and finish steps 2, 3, and 4. All right, you guys. Good luck, okay? Not that hard. Don't be scared. It comes out nice and organically. The magic will appear. Now the rest of the notes, I don't think we're going to actually do it for this class. So don't worry so much about it until I say more about it, all right? So good luck, you guys!